The A321 Neo became aviation's biggest success story of the past decade. Airlines could not get enough of it. Then, a fundamental problem started emerging that Airbus never anticipated. Boeing noticed, and what Boeing is preparing right now could destroy everything Airbus built. Here is the secret weapon Airbus desperately fears. Roughly 550 orders. That single number tells you everything about why Airbus felt invincible heading into 2026. The A321XLR became the fastest growing wide-body replacement narrow-body in commercial aviation history. Transatlantic routes that used to belong exclusively to Boeing's legendary Boeing 757 suddenly appeared on Airbus order books across dozens of airlines. But success has a way of revealing problems that earlier success concealed. The A321XLR is starting to show cracks, not metaphorical cracks. Literal performance limitations that engineers cannot patch with software updates or aerodynamic refinements. And Boeing, after 15 years without launching a single brand new commercial aircraft program, is finally positioning to exploit those cracks with the NMA 797. What happens next could reshape narrowbody aviation for the next generation. Begin with how the A321 family got here. When Airbus first conceived the A321 in the late 1980s, the aircraft was designed for one specific job: move passengers between European cities on routes too dense for the A320 but too thin for wide bodies. That was the entire design brief. A workhorse for medium density, short to medium haul missions. Fast forward through 3 decades of evolution. The A321 became the A321 Neo with new engines. Then airlines wanted more range. Airbus delivered the A321LR with additional fuel capacity. Then airlines wanted even more. The A321XLR arrived with a permanent rear center fuel tank pushing range close to 4,700 nautical miles. Each step seemed incremental. Each step preserved the operational commonality that made airlines love the A320 family. Same type rating for pilots, same maintenance procedures, same parts ecosystem. Each step generated enormous sales success. But here is the engineering reality nobody outside the aerospace world fully appreciated. The A321XLR flies missions that the original A321 design never anticipated. The aircraft taking off from Newark to Naples in 2026 shares fundamental architecture with a 1988 design intended for Paris to Rome. Maximum takeoff weight tells the story most clearly. The original A321 variants operated at roughly 83 tons maximum takeoff weight. The A321XLR pushes past 101 tons. That is a 22% weight increase imposed on essentially the same wing structure. Airbus added sharklets, refined flap configurations, and improved aerodynamics. But the fundamental wing geometry remains largely what it was when George H.W. Bush was president. Engineers describe what happens when you load more weight onto the same wing as increased wing loading. Every square foot of wing surface area now carries more weight than it was originally designed to support. The consequences ripple through every phase of flight. Takeoff performance suffers first. The A321XLR needs longer runways than its predecessors, particularly when operating at maximum weight on hot days. Airlines operating from places like Phoenix, Las Vegas, or Mexico City during summer afternoons sometimes need to restrict payload to maintain safe operations. Hot and high airports compound the difficulties. Higher elevation means thinner air. Higher temperature means thinner air. Thinner air reduces both engine thrust and wing lift simultaneously. An aircraft already operating near its structural limits has very little margin when atmospheric conditions work against it. Climb performance reveals the most operationally problematic limitation. After a fully loaded A321XLR rotates off the runway, the aircraft cannot always climb directly to efficient cruising altitudes. Pilots often spend extended periods at lower flight levels around 31,000 or 33,000 feet, waiting for fuel burn to reduce weight before stepping up to more economical altitudes. That climb behavior matters enormously for fuel economics. The atmosphere becomes dramatically less dense at higher altitudes. An aircraft flying at 41,000 feet encounters roughly half the air density of an aircraft flying at 33,000 feet. Less air density means less drag. Less drag means dramatically lower fuel consumption per mile flown. When an A321XLR spends 2 or 3 hours fighting through denser, lower altitudes before reaching efficient cruise, the aircraft burns extra fuel during exactly the phase of flight where weight reduction matters most. Over a typical long-haul mission, this can amount to significant fuel penalties that airlines absorb on every flight. Atlantic winter operations compound the problem. Headwinds across the North Atlantic intensify during winter months. An aircraft already climbing slowly through dense air faces stronger headwinds at those lower altitudes than it would at optimal cruise levels. Some carriers report A321XLR flights during winter, requiring fuel stops on routes that should theoretically operate nonstop. None of this surprises Airbus engineers. They knew the platform was being stretched. The decision to keep evolving the same airframe, rather than developing an entirely new aircraft, reflected commercial logic that overwhelmed engineering preference. Airlines kept ordering the variant because operational commonality mattered more than perfect performance optimization. Boeing watched all of this unfold. While critics complained about Boeing's lack of new aircraft development, the company was studying exactly how Airbus was painting itself into an engineering corner. The 797 concept Boeing has been refining takes the opposite philosophical approach. Rather than adapting an existing platform to perform missions it was never designed for, Boeing wants to design an aircraft specifically for the middle market mission from a clean sheet. The target profile reportedly centers on 220 to 270 passengers around 5,000 nautical miles of range, and operational economics optimized for long, thin international routes. The 797 essentially replicates the mission the Boeing 757 and Boeing 767 performed during their respective heydays. The fundamental difference between the two approaches becomes most visible in wing design. The A321XLR uses a wing inherited from short-haul operations carrying long-haul weight. The 797 would feature a wing engineered around its intended mission from the ground up. Larger overall wing area. Modern composite construction allowing greater span without prohibitive weight increases. Aerodynamic profile optimized for long-haul cruise efficiency rather than balanced short-haul versatility. Lower wing loading from the start changes everything that follows. Shorter takeoff rolls even at maximum weight. Stronger climb performance, reaching optimal altitudes within minutes rather than hours. Better hot and high performance, because the wing has structural margin, Airbus exhausted years ago. Greater payload flexibility on long routes, because the aircraft is not operating constantly near its design limits. The fuel economics that follow speak for themselves. Aircraft reaching optimal cruise altitudes faster spend more of each flight in the efficient operating envelope. Aircraft with structural margin can operate flexibly across varied conditions without payload restrictions. Aircraft designed for the mission perform the mission better than aircraft adapted for the mission. This is why airlines paying attention to long-term fleet planning are watching Boeing's 797 development carefully. United Airlines has openly discussed needing a true Boeing 757 replacement that the A321XLR cannot fully satisfy. Delta has reportedly briefed its pilot union about preparing for a potentially new aircraft type. Even Ryanair, the largest Boeing 737 operator in the world, has hinted at potentially outgrowing what traditional narrowbodies can offer. The competitive implications extend beyond just stealing A321XLR orders. If Boeing successfully launches the 797, with the engineering advantages a clean sheet design provides, the entire competitive logic of middle market aviation shifts. Airlines that committed to A321XLR fleets based on the assumption that no superior alternative would emerge may face uncomfortable strategic questions in the early 2030s. Airbus is not standing still. The company is studying potential A320 Neo successor programs with target service entry in the late 2030s. But that timeline gives Boeing potentially years of competitive runway if the 797 reaches market faster.